Morning, everybody. So, as we know that today we are going to start the next chapter. That is what carbon and its compounds. So, I think most of you already studied regarding carbon and its compounds. So, let us come to here. You can take notes, Kevin. Okay. So now coming to here, carbon and its compounds. All of you observe. So this entire chapter will run about what is carbon and what is the products or what is the compounds formed by with the help of carbon. So if it comes to the previous chapters and all, as we already studied, what is metals and as well as what is non-metals, and we already studied what about the valency of the metals, non-metals, and as well as this ideal gases, or we can say inert gases. So if you have taken the metals, basically observe their valency will varies from 1, 2, or 3. And non-metals, basically the valency varies from 5, 6, and 7. Those who are reactive. So now like formation of compounds also. But coming to here, non-metals, one more valency will come. What is that, guys? That is only called as 4, if you notice it. So these 4 valency electrons means the outermost shell who is having 4 valency electrons, they will never donate like metals and they will never receive like these non-metals. So the elements who is having 4 valency electrons, they will behave differently. Instead of donation or instead of receiving, they will go with a phenomena called as, what is that called as, guys? Sharing of electrons. Is it yes or no? So instead of donation or receiving, that is what we can say. If anyone can donate and another one can accept, then that is the compounds formed by that we used to call as, what compound we used to call as? Ionic compounds. Now, if the compounds is formed by only sharing, we used to call as, what compounds we used to call as? Covalent. Now we studied the properties of covalent compounds and properties of ionic compounds already in the metals and non-metals chapter. Basically, we will say that the ionic compounds are more stronger, even they're having a high melting points and boiling points and etc. compared to the covalent compounds. But of course, covalent compounds are weaker than ionic compounds. But coming to the compounds formed by carbon, they are basically more even stronger than some ionic compounds also. So that is also we'll discuss here. What is the compounds formed by carbon and carbon and other substances and how it will form, everything we'll discuss here. So in this entire chapter, as it is, everything is there for us. We should study a carbon, how properties of carbon, covalent bond formation, and properties of again we can say like carbon like a self combination, occurrence of carbon, allotropes of carbon, versatile nature of carbon, why carbon is very very important. Next, what is the compounds formed by carbon, that is what organic compounds we will say, hydrocarbons, nomenclature of hydrocarbons, isomerism, homologous series, functional group, chemical properties of carbon compounds, importance of carbon compounds. Next one, soaps and detergents, and last concept is coal and petroleum. So like this, very very big chapter, and as it is a very important chapter also. So one by one we'll study slowly. We'll try to complete as soon as possible. Now coming to here, let us discuss about carbon compounds if we'll take. So first coming to the carbon. So it will take a few days to study about the carbon. Later we'll go to the compounds. So carbon is an element basically we'll represent in our periodic table the symbol of carbon. What is the symbol of carbon, guys? Everybody? Yes, C. And it is a metal or non-metal? All of you. It is a
Non-metal.
okay. Now, this carbon name is derived. How the carbon came? Actually, it is derived from a Latin word called as carbo. So, carbo means basically we used to say coal in Latin. That is how a coal is also a made up of carbon. That is the reason we used to call this one as carbon. Carbon means carbo in Latin, called as coal. So a carbon main constituent of coal is carbon. So that is why it is called as carbon. So now if you will not observe very carefully, the amount of carbon present in earth crust. Earth crust. Earth crust means inside or outside, guys? Understanding? Yes. If you take earth crust, it contains only 0.02 percentage. Understand? That is also in the form of minerals. So the minerals, if you take example like carbonates, which we will study like salts, carbonates, coal, and basically it will be in form of petroleum. So these are the sources of carbon that is also in the form of combined state, not in free state, combined state with the other substances inside the earth crust. So that much percentage is present. And if it comes to the atmosphere if you have taken, so atmosphere carbon, what is the percentage of carbon? Anybody can tell? It has only how much percentage? 0.03 percentage. That is also in the form of what? Not free state. What state? Anybody can tell?
Carbon dioxide.
Carbon dioxide. So that is what you have to, in the form of carbon dioxide, it is present in 0.03 percentage. So even though if you notice it, is very, very small percentage in under earth crust and as well as atmosphere. So in spite of this small amount of carbon available in nature, this carbon element is having very important role in our everyday life. So if you see in our surroundings, it will be everything we can ourselves we can observe a carbon compounds in our surroundings. That is what a carbon compounds, which we used to call as organic compounds. Okay, so most of the compounds which we will see in our surroundings, including our body, everything is made up of one of the substances carbon. All the substances made up of carbon compounds is called as what compounds we used to call? Everybody?
Organic compound.
Is called as organic compounds. So if you take any living things in this nature, all the living organisms, if you have considered, their body is made up of, including the plants and animals, everything is made up of carbon and based on carbon compounds only. So that is why all the compounds we used to call, all the living organisms, including plants and animals, we used to call as organic compounds. Okay, so why means every living organism, a carbon element is present in them. That is why it is a very, very typical non-metal. Of course, even though their percentage is extremely small, but their importance is like we can say, there is no, we cannot define their importance in our daily life. So huge importance in our everybody's life. We can say like immense importance, extremely part of our life. So many things, the compounds of carbon present in living organisms. That is what I'm saying. All of you observe the compounds of carbon which are present in living organisms is called as what compounds we used to say? Organic compounds. Understand? So if we'll see in our daily life, many of the substances in our surroundings made up of carbon compounds only. So if you take our food, what is the food we are consuming? Fastly, you can tell me. What is the food we are consuming?
Carbohydrates.
Grains, the food like pulses, the food like sugar, tea, coffee, fruits, vegetables. These all the things are carbon compounds. Now, if you take the materials, the dresses what we are wearing. Anybody? Cotton dresses, silk dresses, wool, nylon, polyester, both synthetic and as well as normal polyester, normal what we can say fibers, everything, natural fibers and synthetic fibers, everything it is made up of a carbon only. So making cloths are carbon, whatever we are using like this nylon cloths, silk cloths, woolen, everything is carbon compounds. And the fuels, what we are using. So what is the fuel we are using? Anybody? The fuel we are using what? Wood we are using.
Petrol.
We are using kerosene. We are using LPG. We are using CNG, compressed natural gas, LPG, liquefied petroleum gas, liquefied petroleum gas. So all these things, understanding natural gas, next water gas, petrol, diesel, which everything, even cooking, whatever we are using for cooking food, and as well as running vehicles, everything is carbon compounds only. Now, if it comes to here, paper, rubber, plastic, leather, drugs, dyes, everything is also made up of carbon compounds. Means carbon is one of the major constituent of all these compounds. If you see in our surroundings, whatever the most of the things in our daily life is made up of carbon and its compounds only. So yeah, carbohydrates come under carbon compounds only. Yes, Raja, the food what we are eating, vitamins, carbohydrates, entire everything they contains carbon is one of the major substances. So that is why carbon element plays very important role in our daily life. So we can test the presence of carbon in materials on the basis of fact that carbon and its compounds burn in air and they'll give carbon dioxide gas, which turns lime water into milky. So as we already studied in the lower, first three chapters we are studying. What is the test we'll do for carbon dioxide gas? How we can prove that carbon dioxide is releasing? We'll pass through the what?
Crossing into stake line.
Yes, if it will turns into what? Water, that is what? Lime water into what? Lime water into milky. So that is what the testing of carbon dioxide. Even excess will pass, again it will turn into colorless. So like that, if you burn any kind of carbon compounds, if you burn in air, that is what, if you burn in air, definitely they will give carbon dioxide gas, and that carbon dioxide gas is releasing or not, we can test by passing through the lime water. If it will pass us through the lime water, it will turn into what, guys? It will turn into milky. So that is why you can see, burn the given material, whatever the material, you can say either it is a carbon compound or not. So if you burn it, then definitely it will, if it will produce us a gas and the gas is passed through the lime water, if it will turn into milky, then I can say the given material definitely contains what, guys? The given material definitely contains
Carbon.
product of one of the compound of carbon. So that is what we will say that. So this is what basically a general introduction of carbon. Why the carbon and compounds is very important. That is what in 11th and 12th, they will separate the chemistry into two parts, organic chemistry and as well as inorganic chemistry. So this is a basic foundation chapter for entire 11th class chemistry, where people can easily study if you have been very perfect in this chapter, or this level. So now coming to here, this carbon always, as we know, what is a carbon? Is a metal or non-metal? All of you, carbon is a non-metal. So it will never receive the electrons from metals. This carbon always it will forms only one kind of bonds. What is that bonds, everybody? That bonds is called covalent bond. So always carbon will forms only covalent bonds. No ionic bonds will formed by the carbon. So because as we know, carbon symbol is 6 and atomic number is how much, guys? Atomic number how much? Carbon atomic number
6.
6. And if it means in the sense of how many electrons is there in valency shell? How many electrons? 4. Totally 6 electrons. So it will write the electronic configuration. So what is the electronic configuration of carbon? Anybody? K.
2,4.
2,4.
2,4. So what is the valence cell? Valence cell. Valence cell. And it is having 4 electrons in its valence cell. So as we know, valence cell electrons will be 1, 2, 3, 4, 5, 6, 7, 8. Now, if 1 electron, valency is 1, 2 electrons, valency is 2, 3 electrons, valency is 3, 4 electrons, valency is 4, 5 electrons means what, guys? Valency is again 3, 6 means valency is 2, 7 means valency is 1,
1.
means valency is 0. So now, if you have taken 4, so if any kind of atom is having 4 electrons in its valence cell, it will never go under donation or receiving, accepting or donating. It will go under only what?
Sharing electron.
Sharing of electrons. So by sharing of electrons, it will form only covalent bonds. Means all the compounds formed by carbon is always covalent compounds only. So it is not possible to remove 4 electrons from the carbon atom. So that is why it is also not possible to add so many electrons like 4 electrons to the carbon atom. So that is due to energy considerations and all, which we will study in the 11th class. It is not needed now. So that is why to acquire the inert gas, it has to acquire the inert gas. So at any cost. That is why instead of donating or instead of receiving, it will go only under the phenomena called as sharing of electrons. So that is why always the carbon will form what compounds, guys? Only it will form a bond called covalent. So already I taught you types of covalent bonds and all in metals and non-metal chapter. Do you remember that? Yes, single bond, double bond, triple bond. Yes. So now, if any kind of element having 4 electrons in its valence cell, then that property is called as tetravalent. So that is why our carbon is a what valent it is? Carbon is called as tetravalent. Understanding? Means it is having how many electrons in its valence cell? It is having 4 electrons in outermost shell. It will take nucleus. So 6 protons and 6 neutrons will be there. And the first shell, it is having 2 electrons. And the next shell, it is having how many electrons? 4 electrons. Understand, everybody? So if it wants to acquire the nearest stable or inert gas electronic configuration, so it needs to get 4 more electrons to become stable in nature. So that is why you can see the carbon always will form tetravalent. So as we all know, tetra means how many, guys? 4. And valent means valency, means valency is 4. So that is why carbon atom requires 4 electrons to achieve the inert gas electronic configuration. So always carbon is what it is? Carbon is tetravalent. So if you want to represent the carbon tetravalent, you can represent like this. So this is the symbol of carbon is tetravalent. Please all of you note it down. The symbol of carbon is, this is what, why carbon is tetravalent means, because it has 4 electrons in its valence shell. If it needs 4 electrons more to achieve the inert gas electronic configuration. So that is why carbon is always tetravalent. Is it okay, guys? Yes. So that is what we have to remember. So now let us comes to here. After that, then we are going to study the next one is self combination. So this is all versatile nature of carbon. So that is what you all should remember. So first thing, so basically why the carbon is very, very important. So that is what we are studying now. So carbon basically it is versatile in nature. So versatile properties of carbon, that is what we are going to study now. So what is this versatile nature means? As it is, first I said, it is the tetravalency. What is this, guys? Tetravalency. Understanding tetravalent. Now, the second one is called as, remember, that is only called as self combination, or we can say the property is called as, we can say the name of the property is called as, anybody? Don't know? Yes, please. What is the property name called as?
Catenation.
Catenation. This is the most important one. If you don't know this one, you cannot remember that. So you want, you can keep the heading for this. All of you, versatile nature of carbon. Why the carbon is very popular? Why the carbon is very, very important? Because of this one only. So carbon, always it is a tetravalent one. So it is having 4 valence electrons in its valence shell, and it needs 4 more electrons so that it can form many bonds. That is why no other element can show such a unique properties. That is what we used to say, catenation, tetravalency, and as well as multiple bonds. And say last one is, I will say that now it will come isomerism and all. So this is what versatile nature. So coming to the second property, what is the second property name called as, everybody? Catenation. Understanding? So what do you mean by catenation means? Observe carefully, everybody. Due to the smaller size of carbon atom, actually this is very, very important among catenation property. Atom, it will shows maximum catenation property. So what is that? I will explain. Shows maximum catenation property. What do you mean by this? Means, remember, if carbon is not having any other metal or any other any other element, then itself it will form the long chains. So that is the property it is called as. It can form straight chains. It can form branched chains. Do you understand what I am saying? Everybody? Please respond. So that is what is the property called as catenation. So a catenation is the only property shown by the carbon, unique property of carbon, which will having a capacity to form as long straight chain compounds, or it will form branched chain compounds and even rings also. So that is why it is called as a special, a versatile nature of carbon called as catenation. Have you all understand, everybody? So catenation means self combination of carbon atoms to form long chains. So itself, carbon itself, it will form a longest chain. Even thousands of carbons will be together and it will form many number of compounds. So that is why it is called as a versatile nature of carbon. It will form millions of compounds because of this property. So maximum catenation property is shown by carbon. No other element is having this nature which can form very, very longest chains. Have you all understand? Please respond, guys. Yes.
Yes,
So
sir.
like normal metallic chain, it will form straight chains, it will form branched chains, it will form closed ring-like chains also. That is the speciality of carbon. So it can form any kind of branched chains, straight chains, branched chains as closed compounds. That property is called as catenation property, or we can say self-combination. In future classes, we'll study straight chain compounds, branched chain compounds, and as well as rings compounds. Okay, everyone? Are you all understanding? The ring structure. That is what I'm saying, Kevin. So ring structure. So this property, due to this only, carbon can compound. Carbon will form millions of compounds because of this property, catenation. But remember, this property of catenation is exhibited by some other element also. So for example, if you take silicon, silicon also will show catenation. Phosphorus also will show. Please, this is also there. Book also I will show you. Phosphorus also will show, and sulfur also will show. But in these elements, the degree of catenation. Can anybody tell me what do you mean by degree of catenation? What do you mean by what you understanding? Degree of catenation means the capacity to form longest chain. Do you understand? So if you take the carbon, there is no limit for the number of carbons. They can form, suppose 100 carbons also can form the straight chains. Doesn't matter. Continuously it will form many number of carbons can. But that is what degree of catenation is highest. No other element will be like this, like carbon. So that is what it is. No other element can show such unique catenation property. But if we take silicon, phosphorus and sulfur also, somehow they will show the catenation property. But if we take the silicon is the next to the carbon, which is having a little catenation up to some extent only. After that, the chains will automatically break. Suppose if I have taken silicon also can form a catenation property. But if I have taken like carbon, if the carbon will form a catenation property, the chain is very, very strong. Do you understand, everybody? So even though it is a covalent compound, the bond formed by the carbon is very, very strong. But if we take like silicon, the bond will be very, very weaker, and the compounds also will be unstable in nature. That is why a silicon can form maximum 8 branches, means 8 silicons can be together. So after that, one more silicon, like 2 more silicons is trying to together, the chain will become enough weaker and it will be break automatically. That is why the compounds formed by silicon is weaker, and as well as they are unstable in nature. But they also will show the catenation to some extent. That is what we have to remember. But like carbon, no other element will show the property called as catenation property. And also remember, carbon forms stable carbon chain. Do you understand, everybody? The stable, very, very highly stable in nature. Like you can take any long chain molecules, carbon compounds alone, they are very, very high stable. But if you take any other things, silicon, phosphorus, sulfur, they might be also shows the catenation, but only some extent. After that, the chain automatically it will break because the compounds are the bond formed by them is very weaker and they are unstable in nature. So then why sir only carbon it is very strong? Because the carbon particles are very smaller in size. That is what I have told you. The carbon, small size of the carbon atoms, they bonded the electrons very strongly. That is the reason it will form a largest chains called as a catenation property. So what is the reason behind it? Everyone, smaller size of carbon atoms, the bonded electrons are held strongly. So that is the reason a second versatile nature of carbon is catenation. Do you understand everybody? First one is tetravalency of carbon, 4 carbon. How many bonds it will form, guys? How many bonds it will form? 4 bonds. Understanding? So the unique property of carbon, which is also responsible for formation of variety of compounds, is tetravalency. So it can form the compounds with other elements like oxygen, sulfur, nitrogen, halogens by forming the strong covalent bonds. It can form strong covalent bonds. So that is why it can react with all other non-metals like oxygen, sulfur, nitrogen, halogen, everything, and it will form strong covalent bonds. So these different elements form a different compounds with the specific properties. So that is why a tetravalency of a carbon is also a versatile nature, one of the main property of carbon. Why a carbon is very special? Because of its tetravalency, and second one is self combination called as catenation. Okay, now I will show you what is the importance of this catenation property and how other elements are not shown. That is what, if you all are having NCERT book, is it yes guys, all of you?
Yes, sir.
Yeah. So now if you open the chapter, first you can see how it is importance in text, how line to line I am going deep inside, you can understand. So the first one is introduction of this one. So whatever we have studied, whatever I said, you can see everything here, including the word to word, all the things it will be there, including the percentage. Now that is what bonding in carbon, that is what, as we know, what is a bond formed by the carbon, everybody?
Covalent bond.
Covalent bond. Understanding? And if you see, the ionic compounds have basically high melting and boiling points. Yes or no, guys? Last class we studied. Yes? And they will conduct electricity in solution or in molten state. Yes or no? Everybody?
Sir.
But if you see, ionic compounds also basically they are stronger and they are having high melting point and boiling point. But if it comes to here, the compounds, properties of carbon and compounds also, they also will show the properties, that is also we'll study. Even we can see these all the properties I'll teach. Now you can study the versatile nature of carbon and compounds. Here it will be there. Just wait, I'll show you. This all I will teach you. So this is all about compound, that is what allotropies of carbon. So this is also we'll study diamond and graphite and as well as fluorines. Now, versatile nature of carbon. Why